So now let me explain how to express or how to prove the given number is irrational number, right? So before we get into the problem, we need to know these basic things. So first let me explain how to prove root 2 is irrational. Before proving this, you should know this theorem. What is this theorem? Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. If P is going to be a prime number and if P divides A square, then this P will divide A also, right? So what does it says? For example, if P is a prime number, take 2 is a prime number. Now if I say 2 divides 4 square, then 2 will also divide 4. This is what the meaning of this theorem. If a prime number divides any positive integers square, then the same prime number will divide the number itself. I repeat, if a prime number divide any positive integer square, then the same prime number will divide the number itself. That is what the meaning of this theorem. So keep this theorem aside. Now let us come back to this. We need to prove root 2 is irrational. Now first let us going to consider the contrary. Now let us assume root 2 is rational. What will happen if root 2 is a rational number? We know every rational number is of the form P by Q, where P and Q are integers, right? So by definition, root 2 can be written as some R by S, where R and S are integers, right? So what are we going to do? The next step is, if R, there can be two cases. R and S can have a common factor, or R and S cannot have a common factor. If they don't have a common factor, okay, well and good. If at all they have a common factor, what are we going to do is, we are going to divide by the common factor and we are going to reduce it further. We are going to make it as a simplest form, A by B, so that A and B are co-prime. What is meant by co-prime? Co-prime means they do not have a common factor, which means what? A and B do not have common factor other than 1. Do not have common factor other than 1. This is what the meaning of co-prime. This is what the meaning of co-prime. Okay. What we done here, divided by common factor of R and S. We have simplified this. Okay. So now we have arrived root 2 is equal to A by B, where A and B are co-prime numbers. A and B do not have any common factor. Now cross multiply this, what we will get? Root 2B is equal to A. Now we are going to square on both sides, so it will become 2B square is equal to A square. 2B square is equals to A square. Right? Now what does this imply? What does this imply? 2B square is equals to A square means 2 divides A square, right? Then only we will get a equation like this. If I write 2 into 4 is equal to 8, what does it mean? 2 divides 8 and 4 divides 8, right? So the same way here 2 divides A square as well as B square divides A square, but I don't want that now. Whatever I need, I am going to pick it. So 2 divides A square. So according to this theorem, if 2 divides A square, then 2 will also divide A if 2 is a prime number. Yes, here 2 is a prime number, therefore this will imply 2 divides A, right? So mark this as 1 and keep it aside. Now if 2 divides A, how can I write this? Shall I write 2C is equal to A for some integer C? Yes, for some integer C. How can I write this 2C is equal to A? The same concept. 2 divides A. This is the Euclid's lemma. 2 divides A, which means I can write A as a multiple of 2. Yes, 2 divides A, which means what? A can be written as multiple of 2. Then only 2 will divide A. right? Now I am going to substitute a is equals to 2c in which equation? This equation. Mark this as 1 in 1. So what will happen? 2b square is equals to, in the place of a I am going to put 2c, so 2c the whole square. So 2b square is equal to 4c square, because whole square I need to square both. So this will become 2c square. So we got b square is equal to 2c square. So what does this imply immediately? 2 divides b square. Yes or no? Because we got 2c square equal to b square. So this implies, this is same like this. 2 into 4 equal to 8 means 2 divides 8 as well as 4 divides 8. So this implies 2 divides b square. Then by the theorem, what do we know? If 2 is a prime number and if it divides the square, 2 will also divide b. Yes, mark this as 2. Now what you got in 1? 2 divides a, and now we got 2 divides b, which means a and b has a common factor as 2. A and b has a common factor as 2. But which is a contrary to our thing saying that a and b are co-prime. Yes or no? We started initially a and b are co-prime, which means a and b do not have a common factor. But we arrived at a condition that a and b have 2 as a common factor, which is a contradiction. Why we arrived at a contradiction? Because initially we made a wrong assumption that root 2 is a rational number, which cannot possible, and hence root 2 is irrational number. Yes, hope you understood. I repeat the process what we did. We need to prove root 2 is an irrational number. We assumed a contrary, we assumed the opposite way. What happens if root 2 is a rational number? If root 2 is a rational number, according to the definition of a rational number, any rational number is of the form p by q, where p and q are integers. So root 2 can be written as r by s, where r and s are integers. Now what are we going to do? If r and s itself is a co-prime, no problem, but if not, we are going to reduce it further by dividing by its common factor, such that we have arrived at simplest form where a and b are co-prime numbers. Co-prime means what? They do not have a common factor other than 1. Then we cross multiplied it and then we squared on both sides to avoid the square root. We got 2b square equal to a square. What does this statement imply? 2 divides a square. By this theorem, if 2 divides a square, then 2 will divide a, right? Mark this as 1. If 2 divides a, this can be written as, a can be written as multiple of 2. Multiple of 2. Again, now we are going to substitute the value of a here. We got 2b square is equals to 2c the whole square. Then we arrived at a statement b square equal to 2c square. This statement again implies 2 divides b square, right? So which implies 2 divides b. Now we got 2 divides a as well as 2 divides b, which implies 2 is a common factor of a and b, but a and b are co-prime numbers, and hence which is a contradiction. Why this contradiction arises? Because of our wrong assumption that root 2 is rational, and hence root 2 is irrational number. Yes, hope you understood. The same procedure only we are going to follow, keeping this in as our theorem as a result. We are going to follow in proving the given number as a irrational number or irrational number. Let me solve one more example so that you will get a better clarity. Before we solve the problem, I want you to recall this property which we have learnt in class 9. Addition, subtraction, multiplication or division of a rational number and an irrational number end up with an irrational number only. If you add a rational and irrational number, the answer is an irrational number. If you subtract a rational number from an irrational number, your answer is going to be irrational. So whatever arithmetic operation you perform with a rational and an irrational number, you are going to end up with an irrational number. But when you do operations with the two rational numbers, you will end up with a rational number only. These are all the things we have learnt in our class 9. Recall this. Now let me show you how we can prove 5 minus root 3 is irrational. As usual, the same procedure. Let us consider 5 minus root 3 is a rational number. If it is a rational number, it can be expressed as a by b or p by q, where a and b are co-prime numbers, which means we are assuming that it is the simplest form where a and b does not have a common factor other than 1, right? Now after this step, what are we going to do is bring this root 3 to the other side. Try to keep a irrational number on the other side. Root 2 and root 3 are irrational numbers is a standard thing. We know that because those are theorems we have proved. So root 2 and root 3 are irrational numbers. Now 5 minus a by b is equal to root 3. Now take LCM, this will become 5b minus a divided by b equal to root 3. Now if you see this, here a and b are integers, since we have expressed as a rational number, these two are integers. So 5b minus a is anyhow going to be an integer, denominator is also an integer, therefore it is clearly a rational number. But this side root 3 is an irrational number. How can a rational number will be equal to an irrational number? Which is a contradiction. Why we arrived at a contradiction here? Because our assumption is wrong, and hence 5 minus root 3 is an irrational number. This how only you have to prove these kind of problems. So first you have to assume a contrary, then you proceed your problem. Obviously you will arrive at a contradiction again because of your wrong assumption. Then hence you can conclude your problem. Hope you understood. So I want you to try few more problems on this. I'll post you few more questions. You can try on that. If you don't understand, again you tell me. I'll try to explain it in another way. Thank you.